Now continuation of the previous video. Now in last video we just did this command thing, use command window and script file to look at the response of RAM. Now we can do same thing using simulink. So the main idea here is to explain that you can get same response from using simulink and also from command window. So this is a GUI interface. So if you open your Matlab here, so in home and you have this simulink library, just click it. This is the library. So if you look here, we have commonly used blocks here. It provides you block that can have some inputs and give you some outputs, or there are some blocks that has only inputs. Similarly, there are few blocks that are designed to represent the output. Finally, commonly used blocks, normally we have this constant as an input, converters, delays, and so on. Okay, mux and demux, multiplier, and operation. Okay. Similarly, in continuous block, we have different. We have transfer function available here. We have state space form. We have PID controllers available, integral, derivatives, and so on. Similarly, we have dashboard. Okay, so this is the discontinuous one where we can use dead zone and saturation and so on. Now in discrete, we have discrete models, transfer function, and also we have discrete differentials and delays, and also we have discrete PID controller here. So then we have logic, okay, lookup tables where we can put the data and use it. Then we need some math operations, so these are math operation available. Similarly, we have model verifications, model that we can use ports and subsystems. Sometimes we require it to just make a block of a system. Then there are signal attributes that can convert from one to signal. Routing is another available here where we have switches. Okay. Now sync is all that block available where you can display your curve, or you use floating, or you make an output, or you just display the number here, or you take the data to and write in on the file. You can use this block, or you can want to write the data from simulink to the workspace. You can use sim out. Similarly, you can plot the graph using x and y. Similarly, you have output here. So we have other block that based on the sources that we have band input, white noise, clips, clock. We have a constant and we have a clock here, digital. If you look at, we have a ramp here. Okay, we have random number here. We have repeating sequence and so on. We can make our own signal using signal generator or signal builder. We have sine wave here. We have step input, and we have uniform random numbers as input. So we do have user defined functions if you want to write your own function. So these are the blocks that are used, and we also have some additional maths and additional discrete blocks. Okay. Now after that, these blocks, we have some toolboxes that are available. For example, we have aerospace toolbox here, communication system toolbox here, the simulink communication system toolbox for hardware interface. Okay. Now we have computer vision toolbox here. We have control system toolbox here. Okay, where we have Kalman filter, linear parameter varying system block, and linear time invariant system block is available. We have DSP toolbox where you can have signal operation, transforms, and filtering. DSP toolbox that can use for hardware in loop. We have embedded encoders. Okay, so fuzzy logic toolbox is another one. So these are the toolbox, model predictive control, and so on. So these are the toolbox that when you need some specific blocks for a particular tool, you can use it. For example, this is a robust control. When you design it, you need these toolboxes. Okay. Now the simple idea here is to create a model file, as we have a script files for what you say Matlab commands. Here we have a model file, and if we can easily get model file from here. Just click it and we get the model. Okay, so when we get the model file, we just drag and drop ramp. Okay, so this is the model file. Okay, now let me open the library, and in library what I need ramp here. So if you look at, go to the sources and you just choose ramp from here and drag it there. Okay, so this is the ramp. All right, if you look this here lab, we have a ramp, then we have a transfer function. So for transfer function we have to go to the continuous block. Okay, in continuous block we have this transfer function available to us, so I just have to pick my model here. Alright, so I place it side by side. Okay, now I just pick the transfer function and drag there. To look at the response I need some sync, so here I use scope here. Right, just click here and connect it, click here and connect it, and just after this you have to run this, you get the result. Alright, so this is the way you can use the simulink block to calculate or display the response of the system. And here is the first order transfer function. Right, so it is compiling. After compiling, it will start running, and you will get the result. So just if I open the scope, I will get the result, and this is the result of the RAM. So you can see this. Okay, so here again this is the x-axis, this is the y-axis, y is the amplitude axis. Now you can choose from here. Like this, the setting is used to display the data. Setting is open. Okay, this is the setting. So in setting you easily choose the data. So you can have number of axes, you can have auto, or you can use legend here, or you also, if you want to save the data, okay, you can limit the points. If you want to save the data to workspace, just click here and save. This is the name, and this is the type you want to do it, array, structure, or structure with type. Okay, just apply it. So after doing this, you just need to run it again. Alright, when you do that, if you look at the workspace, so it will give you the result. Yes, look here, this is the scope data. So if I wrote scope data, it is available to us. Okay, so we can easily say plot. Okay, we can represent same graph using Matlab figure as scope data. Okay, enter. So if you look at, there are two main columns here. First one is the time scale, and second one is the data. So it's better to just do it. Just wrote that if I put dot here, this means that I am selecting all the rows and then put the column, and this one means that I am selecting the R rows of first column. Against, I want to plot this against the data, which is the ramp response of the first order system, and I have to just put here double dots and 2. Alright, so just now if I look at the figure here, where is, yeah, this is the figure. Alright, so it starts from 0 to 10 and 10. If you look at the scope, you get the same result. Okay, 0 to 10. So you're getting the same result in both cases. So what this help here, it's help you to write the reporting. So when you have to paste your figure in the report, so what you do, just double click on the axis here. Okay. So on this axis you can use the properties and you can change the figure formatting. Okay. So this is very easy. You can change the color, you can grid on, grid off, you can do a lot of things here. Okay. So you can insert X level here, you can insert Y level here, you can grid on here, and you can do all these things. Okay. So this is what we can do using simulink. So now first question you have to do is use the Matlab command to find the ramp response of the first one. So this is the in simulink you can use this using ramp command. Okay. Now